Hello everyone and welcome back to Diksha Karnataka YouTube channel. And today is Sunday and here I am with the solution for KPL mock test 5. So if you have attempted all the questions given in the morning in our WhatsApp group, then you should check all of your answer with me. If you still have not downloaded the question paper, you can go to the WhatsApp channel, download the question paper, answer it quickly in 30 minutes, then you can come back and check the solutions. And if you are just casually just checking the answers, then you are welcome. And if you have seriously attempted the question paper, don't forget to mention how much you scored based on the solution that I am going to give you. Also, it will be very helpful if you continuously participate in this mock test. It is absolutely free question paper shared today morning in our WhatsApp channel. So if you are wondering how I can attempt the test series, you can just simply have to join our WhatsApp group, click on the notification icon there, and whenever we are posting any videos, you will get that update. Now let's start with today's solution. First question: a magnet dropped into a coil of conducting wire along its axis will fall with an acceleration. So this is based on electromagnetic induction. So electromagnetic induction, we know that when we drop a coil through when a magnet is dropped in a coil, a magnet is dropped in a coil, then what happens is according to the Lenz's law, it will the coil will induce some electromagnetic field. An electromagnetic field will be induced in the coil, and that electromagnetic field will have a magnetic field of its own, and this magnetic field will try to oppose the cause of it, that is the falling magnet. So it will try to oppose the falling magnet, so basically it will slow down the falling magnet. So it is actually less than G. So when you are dropping a magnet through a coil, coil will induce a magnetic field which will oppose the falling magnet, so that will there will be an extra force acting opposite to the direction of falling magnet. So that's why the acceleration should be less than G. Okay, now let's move on to the next question. A magnetic flux linked with the coil at any instant t is given by phi equals to 5 t cube minus 100 t plus 300. Right, so the EMF induced in the coil at t is equal to 2 seconds. So we know that induced EMF with magnitude with sign is given by d phi by dt. Right, so just simply we have to find the derivative of that. So it will be simply 5 t cube 5 times 3 t square. Right, this is the differentiation of t cube. So there is a 5 constant there. Now 100t's differentiation is 100 and 300 is a constant, so its differentiation will be 0. Right, so this is the induced EMF at any time t. So we can write this as, let me take this negative sign inside, so it will become 100 minus 15t square. Right, 100 minus 15t square is the induced EMF. Now they have asked you to find the induced EMF at 2 equals to 2 second. So E epsilon will be 100 minus 15 times 4. So t square is 2 square is 4. So 100 minus 60, that is 40 volts. So the induced EMF is 40 volts. So if you have answered minus 40, then you have to check your answer once more. Okay, so it will be plus 40 because induced EMF itself has a negative sign. Now next question: 3 pure inductances of each 1 Henry connected in series, the equivalent inductance of the circuit. So in the AC chapter we know that inductance can be treated as resistance by simply applying this law, XL is equal to omega L. Right, so each of them has same resistances, so we can consider that equivalent inductance is 3XL. They are, you can treat them as simple as resistances, right, because they are proportional to the omega. So it will be simple 3 times omega times L Okay, so what is the equivalent EMF? So suppose equivalent inductance is LEQ, so omega omega will cancel, so LEQ is 3L, that is 3 times 1 Henry, that is 3 Henry. Okay, even if you don't know the law of addition of inductances, you can apply this AC concept and you can still find the equivalent inductance. Now for normal inductances, when inductances are connected in series, their inductances are actually added. They simply like resistances. Okay, simply like resistances, their inductances are added in series, and in parallel we have to use the formula 1 by L1 is equal plus 1 by L2 plus 1 by L3. Right, now let's move on. Question number 4. A current of 4 ampere is set up in a coil of self-inductance 200 millihenry. Okay, so current is given by 4 ampere. Okay, self-inductance L is given by 200 mH. Okay, the energy required to set up the consequent magnetic field. So the energy, we know that energy required is basically work done, and work done is half Li square. So half L is 200 millihenry, milli means 10 to the power of minus 3, and I is 4, so 4 times 4, 2, so it will be 4 to the 8, 8 to the 16, 1600 times 10 to the power of minus 3, so 1.6 joules. Okay, so 1.6 joules is the answer. Simple problem, simple answer, not too much complicated. A long solenoid has 500 turns. When the current of 2 ampere is passed through it, the resulting magnetic flux linked with the each turn of the coil is solenoid is 4 times 10 to the power of minus 3 Weber. The self-inductance of the solenoid is. Now to solve this problem, you have to use the formula that N times phi, this is the phi related to each turn, so total flux is N phi, that should be equals to Li. Okay, this is the formula that you have to use. Okay, now 500 turns is given, each turn the flux linked is 4 times 10 to the power of minus 3 Weber. Okay, L we are trying to find, and current is given as 2 amperes. Okay, so this is the formula. So L is basically 500 times 4 times 10 to the power of minus 3 divided by 2, so it will be 1000 times 10 to the power of minus 3, so that is 1 Henry. Okay, so 1 Henry is the correct answer. Correct answer is option B. Now question number 6. A coil of copper wire having 1000 turns is placed in a magnetic field B is equal to 4 times 10 to the power of minus 3 Tesla, perpendicular to the axis of the coil. So a coil of copper wire having 1000 turns. So number of turns is 1000. Magnetic field is 4 times 10 to the power of minus 3 Tesla. Okay. The cross sectional area is given by 0.05 meter square. Okay. If this coil turns through 180 degree in 0.1 second, then the EMF induced is. So first we have to understand what is the meaning of turning by 180 degrees. Okay, so initially suppose the flask linked, is BA, right? B dot A, here initially they are at 0 degree, so it is B dot A cos theta. So initially the flask is BA, then it will be 4 times 10 to the power of minus 3 times 0.05, right? So we can use this 5 4s are 20. So 0.2 times 10 to the power of minus 3. This is the initial flask linked with the coil. Now when you rotate it to 180 degrees, okay, now the flask, this is initial, flask final will be BA cos 180 degree. Okay, so it will be BA cos 180 degree, that is nothing but minus BA. Okay, so when you turned the circuit to from phi to 0, then minus phi, that means the total flux change is actually total flux change delta phi should be equals to 2 phi I. Okay, so plus BA minus BA, so total flux change is 2 phi I. Okay, magnitude only we are considering, so basically that is only 2 times 10 to the power of 2 times 0.2 times 10 to the power of minus 3. Now what is the induced EMF? Now the induced EMF is given by epsilon is equal to n times d phi dt. We are only considering the magnitude, so sign we are not considering here. So n is 1000, d phi we have calculated this is 0.4 times 10 to the power of minus 3, right? 2 times 0.2, so 0.4. So 0.4 times 10 to the power of minus 3 divided by the time given is 0.1 second, dt is 0.1 second, d phi is 0.4. So now 1000 and 10 to the power of minus 3, they cancel each other, right? So 0.4 by 0.1, so that is 4 volts. So 4 volts is the correct answer. So correct answer is option D. If you have solved it, please mention in the comment that I have solved question 6 correctly. This is a very interesting question, important question. Now, the magnetic flux through a coil of resistance R and having n turns changes from phi 1 to phi 2. Then the magnitude of the charge that passes through the coil is very interesting question. Okay, so the magnetic flux through a coil of resistance, our resistance is given R and having turns changes from phi 1 to phi 2. Okay, then the magnitude. So what is the induced EMF? Magnitude of induced EMF, we know that magnitude of induced EMF is n d phi by dt, right? We have just used this formula in our previous case, right? So n d phi by dt. Now what is current? Current is nothing but voltage divided by resistance, right? Also from the definition of current we know that this is nothing but dq by dt, right? So dq by dt is the current, which is nothing but epsilon by r or 1 by r n d phi by dt. Now dt cancels. So what is the magnitude of charge? dq. dq is nothing but n by r d phi. Now what is d phi here? Changes from phi 1 to phi 2. Okay, you can write phi 1 minus phi 2 or phi 2 minus phi 1, does not matter. Since the options are given phi 2 minus phi 1, I am writing phi 2 minus phi 1. Okay, so if you have checked the option, the charge is flowing through this is n by r phi 2 minus phi 1, so option is option B. Okay, so this is the correct answer. Now let's move on to the next question. A circular coil of mean radius 7 centimeter and having 2000 turns is rotated at the rate of 1000 revolutions per minute in the magnetic field of B equals to 0.5 times 10 to the power of minus 4 Tesla. Then the EMF induced in the coil will be. Interesting question. So induced EMF is given by N B A omega. Okay, N B A omega. This formula you have to remember. If you want the derivation of that, then I can do that, but this is a very easy formula to remember. Having 2000 turns, magnetic field is 0.5 times 10 to the power of minus 4. Okay, A is pi r square and omega is 1000 revolutions per minute. Okay, here revolutions per minute should be given in RPM only. Okay, you should not take it in radian per second, otherwise it will be complicated. So this is the formula that you have to use. Now let us simplify this. So 1 2 3 4 5 6, so 10 to the power of 6 and 10 to the power of minus 4. So 2 times 0.5 times pi times 7 times 10 to the power of minus 2 whole square times 10 square. Okay, You might find it is a little bit complicated. So what all you have done, first of all, this is 3, this is 3 10 to the power of 6. So with this we have reduced 10 to the power of minus 4 to 10 to the power of 2. That part is clear. Now we have written this 2 is left. 2 times 10 to the power of 2 times 0.5 times 1 is insufficient. Now pi r square is the area of the coil, right? So pi r square is the area of the coil. Now r is given 7 centimeter, that is 7 times 10 to the power of minus 2 meters. So I have just written that in terms of meters, right? So 0.5 times 2 is 1. 1 times pi is, now for this we will write pi as 22 by 7, okay, and then this 7 will come 7 times 7, okay, times 10 to the power of minus 4. So minus 2 whole square minus 4 times 10 to the power of square. Okay, so one of the 7s will cancel. One of the 7s will cancel. So what we will get? 22 times 7. 22 times 7 means 20 times 7 is 140. Another 14, that is 154. If you wondering how I have done it, you need a little bit of practice. So it will be 1.54 volts. 1.54, sorry. So, ಸ್ವಲ್ಪ mistake. 1.54 volts. So 1.54 volt is the answer for this question. Now, if rotational velocity of the dynamo of armature is doubled, then the induced EMF will become. So we have just seen the formula that it is NBA omega, right? So the induced EMF is NBA omega. For a dynamo or any rotating coil. So if you increase the omega by 2, so rotating speed means this omega, right? So if you increase the rotational velocity by double, then the induced EMF will also be doubled, that is 2 times, okay? No rocket science, simple problem, simple formula. Now, a jet plane having wingspan of 25 meter is traveling horizontally upwards east with a speed of 3600 km per hour. If the Earth's magnetic field perpendicular to the direction of motion of the plane is 2 times 10 to the power of minus 4 Tesla, then the potential difference between the ends of the wing is. So we know that formula is simple. Induced EMF, in this case V is equal to BVL, okay, but here V is given 3600 km per hour. Now we have to convert it into meter per second. So to do that, we have to multiply by 5 by 18. If you are wondering how we got that factor, you can check that. 1000 meter per second. You can check that yourself, and if you still have any doubt, any questions, you can mention that in the comment. I will make a video on that. Now B is given by what? 2 times 10 to the power of 4 minus 4. V is 1000 and L is 25 meters, right? 25 meter is the wingspan. So 25 times 2 is 50. 25 times 2 is 50. And 10 to the power of minus 4, 10 to the power of 3. 1000 means 10 to the power of 3. So it will become 10 to the power of minus 1, or it will become 5 volt. So 5 volt is the correct answer, right? Now let's move on. A circular disc of radius 0.2 meters is placed in an uniform magnetic field of induction 1 by pi Weber per meter square in such a way that the axis makes an angle 60 degree with B. The magnetic flask linked with the disc is. So we know that induction magnetic field is given by 1 by pi, okay, and radius of the disc is given 0.2. So area is given by pi r square, that is pi times 0.2 whole square, 2 to the 4, 0.04 pi. This is the area. Now we know that flask is basically B dot A. that is BA cos theta. So here B is given 1 by pi, A we have calculated 0.04 pi, okay, and cos theta is cos 60. Cos 60 means what? Cos 60 means half, right? So it will be 0.04 times half, that is 0.02 Weber. Okay, so 0.02 Weber is the correct flask linked with the circuit, linked with the coil. Okay, two solenoids of equal number of turns have their lengths and radii in the same ratio 1:2. The ratio of their self-inductances will be. So now to solve that, what we have to do, we have to write the expression for self-inductance of a coil, right? So self-inductance of a coil is basically dependent on, so self-inductance is mu naught n square A by length L. Okay, now so we can write this as, for suppose the first coil is L1, mu naught is constant, same number of turns it is mentioned, so n square is constant also, area say A1, length say A2, L2, length say L1. Okay, now area is basically pi r square, so we can simple write this as pi r1 square by L1. Similarly, L2 is equals to mu naught n square pi r2 square by L2. So what is L1 by L2? L1 by L2 is r1 square by L1 divided by r2 square by L2, or r1 square L2 by r2 square L1, right? So what we have to do, we have to put the values. Now r1 is to r2, r1 is to r2 is given by 1:2. Also they lengths also have the same ratio. Same ratio means length will also have the same ratio, radius will also have the same ratio. So r1 is to r2 is 1:2, L1 is to L2 is also 1:2. So what we have to do, r1 square by r2 square. So r1 square is 1 square by r2 square is 2 square, L2 is 2 and L1 is 1. So it will be 1 by 4 times 2, so it will be 2. So 1 by 2. So L1 is to L2 will be 1:2, right? So correct answer is option B. Okay, now I have seen students, they have seen, okay, ratio is given 1:2, so I will just blindly answer 1:2, so they get correct answer. Some students think, okay, maybe there is a square relationship, so it will be 1:4. So if you don't solve it, you might guess it, but sometimes the guesswork may be wrong. So you have to solve it. Now, a rod of length 2 meters slides with the speed of 5 meters per second, okay, on a rectangular conducting frame as shown in the figure. There exists a uniform magnetic field of 0.04 Tesla perpendicular to the plane of the figure. If the resistance of the rod is 3 ohm, the current through the rod. Now what is the induced EMF? Induced EMF is BVL. What is B? B is 0.04. V is 5 meters per second, and what is the length of the wire? It is 2 meters. So 0.04 times 10, that is 0.4 volts. Okay, this is the induced EMF. Now current is V by R, here epsilon by R, 0.4 divided by 3, right? So 0.4 divided by 3, 4 by 3 is 1.33, if you remember, right? So 0.4 divided by 3 will be 0.133. So it will be 133, this is amperes, or 133 milliamperes. right? So 133 milliamperes is the correct answer. So don't get confused. You have solved 1.133. Okay, then you might think, okay, maybe I have made some decimal mistake. So the correct answer should be 1.33 and they have ticked it. So be careful while answering such question. Now, the time taken by AC of 50 Hertz in reaching from 0 to maximum value. So the frequency is given as 50 Hertz. So omega is 2 pi f, that is 2 pi times 50, that is 100 pi. Okay, you should remember that if frequency is 50 Hertz, omega will also always be 100 pi. Now we know that V equals to Vm sin omega t, right? This is the standard AC formula. Now when this value reaches maximum, then this will be Vm. So Vm sin, what is omega? Omega is 100 pi. We are trying to find this time t. So what will be the value? So sin 100 pi t equals to Vm by Vm, that is 1. Now when sin's value is 1, yes, sin pi by 2, 90 degrees, right? 90 degrees means pi by 2. Now here when you are solving such kind of problems, you have to use the radians value, not the degree value. Okay, this is one caution. So 100 pi t equals to pi by 2. So t equals to pi by 2 times 100 pi. Pi cancels, so 1 by 200. So 1 by 200 means how much? Half times 0 by 10 to the power minus 2 second, or 0.5 times 10 to the power of minus 2 seconds. Now let's check the answer. So from that I have to make it 5 times 10 to the power of minus 3 seconds. Right, so I have removed the decimal, so I have to increase the power, decrease the power by minus 1, so it will be minus 3 seconds, right? So correct answer is option B. Oh, okay, if you are practicing more and more problems, these kind of calculations will be easier for you. I know most of you are struggling to do calculations. Even if you are able to solve the problems, even if you are able to apply the concept, at the last stage you are not able to finalize the answer. So that if the problem that you are suffering from is this, then you have to definitely appear for each and every KPL and solve the numericals without using any calculators. Okay, an alternating voltage of frequency 50 Hz is fed to a circuit having a resistance 628 ohm and inductance of 2 Henry. The phase angle between the current and the voltages. So how can you find the phase angle? So if you remember, in AC we have find the phase angle tan phi equals to XL minus XC by R, right? XL minus XC by R. So in this case there is no capacitance, so XC you can consider XC to be 0. Okay, you can consider XC to be 0, only XL is there. Okay, XL is what? XL is nothing but omega L. Okay, and here frequency is given, so omega will become 2 pi f L by R. So omega is 2 pi f. So we have simply put those values. Now let us insert the values and check the value of tan theta. 2 pi f is 50, this is 2 Henry, and resistance is 628. Okay, so this is the phase angle. So what we will do? 50 times 2 is 100, 100 times 2 is 200, 200 times pi is 3.14 by 628. Now if you multiply 200 with 3, you will get 600, right? Similarly, if you multiply 3.14, then you have to add this, that is 14 the 2, that is 28, you have to add that, so you will get 628. Okay, if you are smart enough, you can guess that this should be 628 divided by 628, So it will cancel, you will get 1. So tan phi equals to 1. Now when the phi value is tan phi is 1, that means phi should be 45 degrees or pi by 4. Based on the options given, you can mark the correct answer. Okay, simple. Okay, this only one formula, if you remember, you can answer this question. Okay, XL minus XC by R. Now the value of alternating voltage V in the given circuit will be. So what they have asked you to find the maximum value of the input voltage V. I have already solved similar questions during our PYQ solutions. So V is square root of VR square plus VL minus VC whole square. Okay, so what is VR? VR is 80. So from the given data only I can guess what will be the answer. Okay, I don't need to solve. 40 minus 100 whole square. Okay, so V will be 80 square, okay, plus 60 square. Okay, 40 minus 100 is minus 60, but there is a square involved. So you can simply write this as 60 square. Now 80 plus 60 square, I know the answer is 100. Okay. So if you are still wondering how I have solved it, you solve it yourself. This is a simple square root formula. Okay, and solve it and tell me the answer. If you remember this, it will be very helpful for you, especially for AC related problems. This is a very common value given across JEE, NEET and KCET. Okay, now let's move on. A resistor and a capacitor are connected in series with an AC source. If the potential drop across the capacitor is 5 volt and that across the resistor is 12 volt, then the applied voltage is. Simple problem. 12 plus 5 17. No? Yes. If you are saying 12 plus 5 17 correct answer, then unfortunately you are wrong. So the correct option is C. Same formula, okay, VR square plus VL minus VC's whole square. Now if VL is 0, VR square, if VC is 0, then VL square. Okay, so here there is no inductor, so VL is 0, so only VC square. Okay, so it will be VR is 12 volt, 12 square, VC is 5 volt, 5 square. Okay, so it will be 144 plus 25, that is 169, that is 13 volt. Okay, it's not 17 volts, it's 13 volt. Okay, not 17 volt, not 12 minus 5 7 volts, it is 13 volts. So you have to be careful while solving AC problems. Even though they appear very simple, there are some tricks involved. In a series resonant RLC circuit, the voltage across R is 100 volts. So VR is given 100 volts. Okay, and the value of the resistance is 1000 ohm. So resistance is 1000 ohm. Okay, the capacitance of the capacitor is 2 times 10 to the power minus 6 farad. So capacitance is given as 2 times 10 to the power of minus 6 farad, that is 2 microfarad. Angular frequency of the AC is 200 radian per second. So angular frequency means omega. Omega is given 200 radian per second. Okay, then the magnitude of the potential difference across the inductor coil. Now no information at all is given about inductor. So how you can solve it? No inductance is given, nothing is given. This is a really very beautiful problem. In the entire question paper, this question is very close to my heart. I have solved it and I enjoyed this solving it. I hope same is for you. So when there is a R, there is a C, there is a L and an AC. In series resonant, when the circuit is in resonant condition, okay, when the circuit is in resonant condition, okay, voltage across the capacitor, that is VC, that should be equals to the voltage across the inductor. So VC should be equals to VL. Okay, so this is the things that you need to know to answer this question. In resonant condition, voltage across capacitor and inductor will be same. So what we will do, we will find the voltage across the capacitor, then that same voltage will be across the inductor as well. Now how can we find the voltage across the capacitor? So first of all, the value of VR is given and value of resistance is also given. So if you know the potential difference across any resistor and if we know the value of the resistance, then from Ohm's law we can calculate the current. V is equal to IR. Okay, so here VR. Now whatever current is flowing through this resistance, because they are connected in series, the same current will pass through VC and VL, right? So first let us find the current. Current is VR is given by 100 divided by resistance 1000, that is 0.1 ampere is the current. 0.1 ampere is the current. Now what will be VC? VC, if you remember, VC is XC I, right? Here also Ohm's law, but instead of R we are going to use XC. What is XC? XC is 1 by omega C, sorry, 1 by omega C times I. Now omega is given 200, C is given 2 times 10 to the power of minus 6. Now let me calculate the omega C here, then I can save some space. So 1 by omega C is 1 by 200 times 2 times 10 to the power of minus 6. So it will be 10 to the power of 6 divided by 400. Okay, so 10 to the power of 4 divided by 4, or I can write this as 100 times 10 to the power of 2 by 4. So it will be 25. So 25 times 10 to the power of 2, that is 2500. This is XC. So XC is 2500. So instead of doing the mathematics here, what we will do is simply write the value. 2500 times I is 0.1. So the VC is 250 volt. The same value will be for inductor as well, because the circuit is in resonance condition. Okay, so for resonance condition, the voltage across capacitor should be same across the inductor. So the correct answer is option D, 250 volt. Very interesting, very important question. Not difficult in terms of mathematics, not difficult in terms of formula, but difficult in terms of concept, right? Now, in the series LCR circuit shown, the impedance is, so here L is given 1 Henry, C is given 20 microfarad, R is given 300 ohms. So what is the impedance? So impedance is nothing but we know that Z is basically square root of R square plus XL minus XC whole square. So first we will calculate XL. Okay, XL is omega L. What is omega here? Omega is not given, but frequency is given 2 pi f times L. 2 pi f is given 50 by pi and L is 1 Henry. So they have given the values such a way that you can simply calculate XL. Now what is XC? XC is 1 by 2 pi FC, right? 1 by 2 pi FC. So 1 by 2 pi times 50 by pi times 20 microfarad. So 20 times 10 to the power of minus 6, right? So it will be cancelled. So 50 times 100, 100 times 20 is 2000. Who is saying 200? 100 times 20 is 2000, right? So now XC will be 10 to the power of 6 divided by 2000, that is 10 to the power of 3 divided by 2, that is 1000 divided by 2, that is 500. So we have calculated XC, we have calculated XL. R is given already 300, right? 300. So we have to just calculate the impedance. So 300 whole square plus 100 minus 500 whole square. It does not matter because there is a square outside. So no matter what you do, 300 square plus 400 square. Okay, the sign here will always be positive. Now we can take 100 square and take it out of the square root. I told you the technique. So 3 square plus 4 square. Now 3 square plus 4 square is a known value. We know that this is equals to 5. So 5 ohm, 500 ohm is the value of the inductance. So impedance. So impedance is, correct answer is option A, 500. Simple. So now you tell me if you know 3 square plus 4 square is equal to 5 or not. Now AC supply is represented by V is equal to 141.4 sine 100t. So 100 is the omega. Okay, is applied to a series LCR circuit of impedance 50 ohm. So impedance is given itself, where the resistance has a value of 40 ohm. The circuit is behaving capacitive. The RMS value of the current in the circuit. So these are all, there are a lot of extra information is given. So first what we will have to do, we have to find the current. Current is nothing but voltage divided by impedance. If impedance is given, we don't have to do anything else, right? So voltage is 141.4 sine 100t divided by Z, that is 50. So from this we can write 141.4 by 50 sine 100t. Okay, 100t plus phi, there will be a phase term as well, because obviously this is not in phase. So some phase term will be there. But we are not bothered. What we are interested is this form, right? So from this, what we can write is that the IM, the maximum value of current, is 141.4 by 50. Okay, so what is the RMS current? RMS current, we know that RMS current is given by I max by √2. So I RMS, sometimes written as capital I, is equals to I max by √2. So 141.4 times not times, divided by 40 50 times √2. Now √2 is 1.414, right? So what will be happening here? If you cancel this, you will get 100. So 100 by 50, that is 2. So I RMS is 2 ampere. Okay, so correct answer is 2 ampere, option C. 21. A multimeter reads a voltage of a certain AC source as 100 volts. What is the peak value of the AC source? Now we know that multimeter or any AC meter, whenever they are reading the RMS value. Okay, they can only read RMS value. So I RMS, VRMS is 100 volts, that is peak value divided by √2. So peak value is 100 √2, that is 100 times 1.414, that is 141.4, right? So 141.4 is the correct answer. Now the options are given such a way that it is very obvious that obviously it will not be 100, 200 or 400 answer. So you can guess the answer in this case. Now a capacitor of capacitance 10 microfarad is connected to an AC source and an AC ammeter. If the source voltage varies as V equals to 50 √2 sine 100t, then the reading of the ammeter is again AC ammeter. Any AC device, they can measure only the RMS values. Okay, so what we have to do, we have to find the RMS current. Okay, so they have asked you to find the reading of the ammeter. Don't get scared if in AC ammeter, wow, what is the AC ammeter? AC ammeter can read only any ammeter whenever connected in an LCR circuit, they can measure the RMS value only. Okay, it is nothing to do with anything else. So capacitor of capacitance 10 microfarad is connected to an AC source and AC ammeter, right? So what is the so first of all, we have to find the current. To find the current, only capacitance is connected. So only capacitance is connected means first of all you have to find the capacitive reactance, that is XC 1 by omega C. Okay, sin omega t, so omega is 100, C is 10 microfarad, right? So it will be 10 to the power of 3, that is 1000, right? So 100 times 10 is 1000, 1000 times 10 to the power of minus 6 is 10 to the power of minus 3. So 10 to the power minus 3 is division, so it will go up and it will become 10 to the power of 3, right? These steps you have to do it faster. Now what is the maximum value of current? First of all, maximum value of current is Vmax by Xc. Vmax is 50 root 2 divided by 1000. Okay, so 1 0 cancels, it will be 20. So root 2 by 20. Now what is RMS current? IRMS equals to I max by root 2. So root 2 by 20 times root 2. So it is 1 by 20. 1 by 20 means what? 1 by 20 means if you, this is ampere, right? So we want to convert it into milliampere for convenience. So let me convert it into milliampere. Okay, to convert it into milliampere, you have to multiply it with 1000. So 50 milliampere is the value of the RMS current, that is the reading by the ammeter, right? Now, when 100 volt DC is applied across a coil, a current of 1 ampere flows through it. So current through a device is 1 ampere when 100 volt DC is applied. Okay, when 100 volt 50 hertz AC is applied to the same coil, only 0.5 ampere flows. So the inductance of the coil is, so basically when you have a resistance and inductance connected, okay, and if you connect this to a DC circuit, okay, I told you that this will be simply, you can simply remove this part and you can consider this is shorted, so it will not resist anything, it will simply allow the current to pass through it. Initially there will be a resistance, but after very quickly it will get saturated and then the steady current will start flowing through the inductor. So you can consider only the resistance is connected, only the voltage is connected. So if there is a current I, only resistance is connected, so in that case we can simply calculate the resistance R. Okay, so voltage is 100, and the current passing through is 1 ampere, so the resistance is 100, right? Now next, when you have connected it to an AC of 50 hertz, then that time you have to consider the impedance of the circuit. Impedance of the circuit, okay, same formula, even though the formula will be same, okay, but instead of resistance, now we have to consider the impedance. So impedance is 100 divided by 0.5, that is 200 ohm. Simple. Now we know that impedance is nothing but square root of R square plus XL square, right? X is 0, no capacitor is connected, so only XL will be there, XL square, right? So if you square it both sides, Z square equals to R square plus XL square, or XL square is equal to R square minus, sorry, XL square is Z square minus R square. Now what is Z? Z is 200, that is square is 400,000, right? 400, 100 minus, that is 30000. Okay, so XL is root 3 times 100. So this is 100. So root 3 times 100 is the XL. So, but that is not the case. We have to find the value of the inductance. Now, what is XL? XL is omega L, right? And what else? Omega is given. No, omega is not given. Frequency is given. So 2 pi times 50 times L is root 3 times 100. Okay, so 2 pi 50 means 100 pi times L is equal to root 3 times 100. So this 100 cancels. So L is equal to root 3 by pi. So L equals to root 3 by pi. So correct answer is option C. This is also very interesting question. Now the following circuit, VC is 40 volts. Then VR and the current are approximately. Now we know that this voltage V is VR square plus VC square, right? So what is V? V is given 50. VR we don't know. Let me do one thing. Okay, let me square both sides. It will be helpful. So V square is equal to VR square plus VC square, or VR square is equal to V square minus VC square, right? So VR square equals to V square is 50 square. 50 square means 5 5s are 25, 1020 minus VC. VC is what? VC is 40 volt, for 4 4s are 16, 1020. Right? So 10 another 0. That is how I do it. Okay, so it is 900. So VR is 300, right? So we have calculated VR. Sorry, not 300, 30. 30 square is 900, right? So we have calculated VR. Now what we have to do? We have to calculate the current. So we have already used this formula also once. So current is VR by R. So 30 divided by 60 ohms. That is 0.5 ampere. So the correct answer is, I think this will be, this was given in your question paper, this was given as ampere, right? So 30 volt, 0.5 ampere, right? Now let's move on. An ideal transformer has a turns ratio of 10 when the primary is connected to 220 volt 50 hertz AC source. The power output is. Now we know that whenever an ideal transformer is used, the power input is equals to power output. So equal to the power input. So output will always be equals to input as long as it's an ideal transformer. Okay. Now in an LCR circuit at resonance, okay, the current is maximum. The current and voltage are in phase. The current lead the voltage by pi by 2. The impedance is maximum. Current is, here it is given as minimum. But current is maximum at resonance. Impedance is minimum at resonance. The phase difference is 0. There is no phase difference. So current and voltage are in phase, right? I hope I have discussed this question. The average power dissipated in a pure inductor. Average power dissipated in a pure inductor is 0. In ideal transformer, the voltage and the current in the primary are 200 volts, 2 ampere, and that the secondary are 2000 volt I ampere. The value of I is, so what is the power input? Power input is power input is Vp Ip equals to Vs Is. P stands for primary, S stands for secondary, right? So in the primary, voltage is 200 and current is 2 ampere. In the secondary, the voltage is 2000 and current is I. So I is 400 divided by 2000. So it will be 5. So 1 by 5 means 0.2 ampere. So 0.2 ampere is the correct answer, right? Now, a step down transformer reduces the voltage of a transmission line from 2200 volt to 220 volt. The power output is 880 watt and the efficiency is 88%. The input current is. Okay, so this is a very interesting question. Okay, they have asked you the input current, okay, and they have given you the output power is, and they have also given you the voltage. Now we know that what is the power output? Our power output is 880 watt, right? So if the power input, say power input is P, if the power input is P, then what will be the power output? Power output will be 88% of that, right? So 88 by 100. So this is power input. Okay, power input is 88 by 100. So that is given as 880 watts. Power output is given 880 watts. So what is power input? If you calculate that, your problem is solved. So 880 times 100 divided by 88. 88 times 1, 10, so 1000. So power input is 1000. Now we know that input voltage, primary voltage, that is in times input current, should be power input. Okay, this is the formula that we use for ideal transformer. This is not an ideal transformer. So power input is 1000. Okay, and the voltage input is 2200, right? So IP is equal to 1000, or IP is equal to 1000 divided by 2200, 0, 0. So it will be 1 by 2.2. So almost equals to 0.5 ampere. Okay, so from the given option, correct answer is 0.4 ampere. Okay, so we have to take the closest answer. Okay, it is not exactly 0.5, it is less than 0.5. Okay, so that's why we have taken the correct answer to be 0.4. Okay, so 1 by 2.2 is close to 0.5 but less than 0.5, because 1 by 2 is 0.5 and 1 by 2.2 will be something less than 0.5. So we can assume that is very close to 0.4 ampere. So this is the closest answer. A step down transformer has 50 turns on secondary and 1000 turns in the primary winding. If a transformer is connected to 220 volt 1 ampere AC source, what is the output current of the transformer? So first of all, what is the input power? Power input is 220 volt times 1, right? And what is output power? Output power will be voltage secondary times I secondary. Now we have to find this, and because it is an ideal transformer, P in should be equals to P out, right? First of all, you have to find Vs. So we know that Vp by Vs equals to Np by Ns. So Vp is 220 volts, Vs we don't know, Np is 50 and Ns NP is 1000 and NS is 50. So it will be 20. So Vs is 220 by 20, that is 11. So now let us put the values here. 220 times 1 equals to 11 times Is. So Is is 220 divided by 11, that is 20 amperes. So 20 ampere is the answer, right? So I hope you have enjoyed today's session, and let me know how much you scored in the comment below. I will be back with a new lecture tomorrow, and KPL session will be continuing, and next Sunday we will have KPL match number 6. Till then, tata, bye bye. I will see you tomorrow.